All right, guys, I'm out today with an appointment, but I've got this video. So watching this video will count as your attendance. This will count as our lesson for the week. So Thursday will not be a mandatory class. It'll only be mandatory for those who have a grade below 70% and anyone that needs to come and ask questions. So if I don't see you again, have a great spring break. But let's look at what we have this week. Okay, looking at our grade screen as usual. We see that this was last week. This has been turned in, hadn't been graded yet. But so what's due the 17th, right here before spring break, matrix row operations and quiz number one. Quiz number one is actually here on Buzz, but Khan Academy is the matrix row operations. So we'll take a look at that. Don't wait till late in the week. Make your spring break longer. Get this done early. But let's take a look at the matrix row operations here. When you click on, oops, I got to go back to activities. If I go to, let's see, matrix row operations right there. So let's look at that lesson and then we'll take a look at the assignment and all that. Make sure you're logged in when you get here. It should have your name up in the corner when you get to Khan Academy. So if you're not logged in, log in. It will help keep track of everything you've done in here as well if you forget to copy and paste something. All right, let's look at matrix row operations. And all right, the following table summarizes the three elementary matrix row operations. So here's the three things that we're going to play with. We could switch any two rows in a matrix. All right, if we have 2, 5, 3, 3, 4, 6, we could switch that and we could do 3, 4, 6, 2, 5, 3. That's fine. It doesn't affect anything. It'll still work the same. See, interchange row 1 and 2. We could just do that. Or we can multiply a row by a non-zero constant. We can't multiply by 0. We're not trying to get rid of a row. But let's say we took the first row and we multiply by 3. So it's 3 times 2 and 3 times 5 and 3 times 3. So let's do 2, 5, 3. It becomes 6, 15, 9. And notice we don't do anything to the second row. We just multiplied row 1 becomes 3 times itself. Another thing we could do is we could add 2 rows together. Row 1 stays the same, 2, 5, 3, but the second row becomes the total of rows 1 and 2. So instead of 3, 4, 6, we're going to take 2 plus 3, make that 5, 5 plus 4, and make that 9, and 3 plus 6, make that 9. So that's the three things that we're going to be doing with matrices in this lesson. So these are used to solve systems of equations. But let's look at these. All right. Switching any two rows. This is how they write it. Perform the row operation, row 1, and then double arrows pointing both ways. Row 2. And that means take row 1 and row 2 and switch places. So if the matrix originally looks like this, 4, 8, 3, 2, 4, 5, 7, 1, 2, and then we change that, now it's 2, 4, 5, 4, 8, 3, 7, 1, 2. Notice the 7, 1, 2 is still the 7, 1, 2. Nothing changed on the bottom. We just took the first and second rows and we replaced them. All right, sometimes we'll see this notation used. Here's the original matrix. Then it says row 1 and row 2 are replaced. And so here's the new matrix. And you can see they just simply took the numbers and switched places. The third row stays exactly the same. All right, so here's a problem for us. Perform the row operation R2, double arrows, R3 on the following matrix. So what numbers are going to go on the top row? If we perform this row operation, R2, double arrow, R3, on this 3 by 3 matrix, what numbers are we putting on the front row? This says take the second row and the third row and replace them. That means nothing happens to the first row. The first row is 7 to 9. So what's the second row going to be now? Whatever the third row is becomes the second row because it tells us to swap those here. So the third row was 1, 3, 12. So now that's the second row. And the second row moves down to be the third row because that's what they ask us to do in this row operation. Check it. Good job. Next question. All right, how about this one? Perform the row operation R3, double arrow, R1. What are we going to put on the first row? Let's see. I'm seeing 0, -4, and 10. That's what people put in there. What about the second row of our matrix? What is that going to be? Yeah, it didn't say to do anything with the second row, so it just remains the same. It did not mention the second row. So now the third row and the first row changing places means, yeah, we have to put the 2 and the 11 and the -5 in there. Check that. Hey, we're good. All right, let's practice the second one, multiplying a row by a non-zero constant. All right, so perform the row operation 3R2, and there's an arrow that says that becomes the new R2. So if we look at the sample using this matrix, 6, 6, 1, 2, 3, 0, 4, 5, 9, 3R2, arrow R2, means replace the second row with 3 times itself. So the first row and the third row are unchanged. It didn't say to do anything with those. So they stay exactly the same, 6, 6, 1, 4, 5, 9. But the second row, which was 2, 3, 0, is now every element is multiplied by 3. 3 times 2, 3 times 3, and 3 times 0. So instead of 2, 3, 0 is now 6, 9, 0. Multiplied the second row times 3 and left it as the second row. All right, so let's practice this one now. Perform this row operation, 2R1, arrow R1. So 2 times row 1 becomes the new row 1. So what's row 1 going to be now? We've got our matrix of 2, 6, 5, 1, 7, 4, 8, 0. Yeah, if we're taking 2 times row 1, and it's becoming row 1, so it's staying row 1, but we just double everything because we take it all times 2. 2 times 2 is 4, 6 times 2 is 12, 5 times 2 is 10, and 1 times 2 is 2. And nothing happened to the second row, so it just stays what it was. All right, great job. Let's try the next question. This one's a little different. We got a 3 by 2. And it says do -5 row 3, so -5 times row 3, and replace row 3 with that new numbers. So notice the first one is unchanged because it didn't say do anything with the first row. It didn't say to do anything with the second row, so we'll leave the second row alone. If we take -3 times -5, positive 15. If we take 6 times -5, negative 30. Let's check and see if that's right. Perfect. And if you go back and you're looking at this and you don't understand that, here's the explanation. You click that, and it tells you what to do. This means replace the third row with -5 times itself. -3 times -5. -5 times positive 6. All right. And here's the last thing that we're practicing. Add one row to another. So if this says R1 plus R2 replaces R2, and we start with this matrix, the first row still stays the first row because it did not say replace the first row. So we take the first row and it's still 2, 3, 4. The second row, it told us to replace that with row 1 plus row 2. So we take 2 plus 0. We take 3 plus 8. We take 4 plus 1. So the new second row becomes 2, 11, and 5. Notice the first row stays the same because it did not say to do anything about replacing that. We're only replacing the second one. All right, so let's practice that now. Oh, and then we have a challenge problem down here. Woo, challenge problem. All right, let's do this first. Perform the row operation. Row 1 plus row 3 replaces row 3. Okay, row 1, it did not say to replace row 1, so we'll leave row 1 as it is. Row 2 isn't even mentioned, so we'll leave it as it is. But what's the new row 3? It says to add row 1 and row 3 together and replace row 3 with that new numbers. -1 plus 7, the first row plus the third row. That would be a 6. 6 plus 2. That'd be an 8. -2 plus a +1. So now we're only on -1. Check. Ah, very good. So I need another one of these. This one says take row 2 and row 3, add them together, and replace row 2. So row 1 stays the same, -4, 12, 9. And row 3 stays the same. So let's go do that. 1, 5, 10. But row 2 is being replaced by row 2 plus row 3. You guys are on this. 8 plus 9 and 12. 8, 9, and 12. Just adding those two numbers together, row 2 and row 3. All right, let's look at this challenge problem they've given us. Perform the row operation. Row 1 plus 2 times row 3 becomes the new row 1. Ooh, getting tricky. So the new row 1 is going to be what? Okay, so row 1 is -5, 7, and 3. All right, and up here it says row 1 plus 2 times row 3 replaces row 1. So 2 times row 3. Row 3 is 8, 8, and -6. So if we take all those times 2, 8 times 2, 8 times 2, -6 times 2. It says to take row 1 and add that to it. So we're going to add these to row 1. -5 plus 16. -5 plus 16. 3 plus -12. So -5 plus 16 is 11. 7 plus 16 is 23. 3 plus a -12. So this should be our new row 1 because it says take this. Up here it says replace row 1. 11, 23, -9. Now, it didn't say to do anything with the other rows, so they should still be the same. It didn't say to replace those. It said only replace the first row. So let's check. All right, that's how you do it. Follow what it says there. All right. Now we're going to talk about an augmented matrix because we're going to use some of these operations in an augmented matrix. So before we talked about, let me see, I'm gonna put this on paper too. So if we have this system of equations, system of linear equations, we can turn that into an augmented matrix. This is the X column, right? This is the X's. 2 and 1. That's the coefficients. So this is the Y column. Coefficient is 4 on the first equation, and the coefficient is -3. And then we can do this little bitty line right here. I'm going to make it a dashed line. And that means really that we have an equal sign. And I'm going to put the 6 and the -7. So this is the constant, all right, just the number. When we add this little line to show where the equal sign is, this is called an augmented matrix. An augmented matrix. So here, when we work with that, we can do any of those operations that we did above, right? So if we have this system of equations with the augmented matrix that represents it, we could swap the rows. It doesn't matter if we write the system of equations in this order or if we reverse it and change the order. That's why we can do that to the matrix. We can swap the rows, just write them in a different order. It's still equivalent. It doesn't matter. Multiplying a row by a non-zero constant. So in this, looking back at the one I have here, if we multiply this by -2 plus 6y equals 14, these two equations are still equal to each other. I just took this one and I multiplied it by -2. But since I multiplied both sides of the equal sign, it's just still equal to each other. -2x plus 6y would equal 14 because x minus 3y equals -7. And I just multiply it by -2. So that's why we can do that to any one of these rows. We can multiply it by a -2 or something. It doesn't change what x and y equals. So they multiplied theirs by -2 to change the equation. That's fine. And then adding one row to another. We can also do that. When we solve linear equations, that's what we usually do. Remember, we would have a -2x and add a 2x to it to make the x disappear, where that would just leave us with a y. Y equals -4. That's how we solve. That's one of the methods we used to solve linear equations. So we can certainly do that with a matrix. So you might see these different operations. If we were trying to solve this, 2, 2, 10, -2, -3, 3, first thing we do is think, okay, let's subtract a row. Actually, let me step through it on the problem that I have right here, because I'll show you why we're doing this. All right. So let's go back to the original matrix I had right here. 2, 4, 6, 1, -3, -7. All right, there's my augmented matrix. And I'm trying to solve this for x and y. All right, the x and the y are the constant. What I'd like to get is just having, what does x equal? What x with no y's equals something. In the other row, I don't want any x's. I want one y, and I want it to equal something. So I want my matrix to look like this. So that way, this is just x, no y's, and it equals whatever. And this would be no x's, but one y equal. So then I'd have the solution. If I could get my matrix to be one x and one y with no other variable in the same line. So how can I do that with this? All right, well, the first thing I should try to do is to get a 1 right here. So one thing I could do to get a 1 right here instead of a 2 is, well, let me subtract the rows. So the first thing I do, I'm going to take row 2, subtract, I'm going to take row 1. I can do it now. Row 1 minus row 2, and I'll replace row 1. Okay. Row 1 minus row 2 and replace row 1. So row 1 now becomes 2 minus 1 is 1. 4 minus a -3 becomes a 7. 6 minus a -7 becomes a 13. And I didn't do anything to the second row. Okay, so this operation got me to have just a 1. I'm trying to get just a 1. That's a good start. I just try to get a 1 there and a 1 there, and then get the answers over here. Now I need a 0 over here. A 0. So let's see, how could I make a 0 in the second column? Okay, so I could take row 1 minus row 2 again. right? I can do the same thing and just replace row 2 this time. So if I do row 1 and subtract row 2 and replace row 2 this time, right, doing that. 1 minus 1 is 0. So let's see, I'm not doing anything to the first row this time. But 1 minus 1 is 0. I'm replacing row 2. 7 minus negative 3. 13 minus negative 7. All right, I'm closer now. Because now I've got the 1, 0. So the X column is done. The X column is done. Now I've got to get the Y column. So I need to change this matrix to where this now is a 1. So let's just multiply this. Let's do row. Oh, let me put the number at front. I'm going to multiply 1/10 times row 2 and replace row 2. So the first row doesn't change because I didn't do anything to it. But what's 0 times 1/10? If you multiply by 1/10, that's like dividing by 10, right? Well, that's still a 0. 10 times 1/10 is 1. 20 times 1/10 is 2. Oh, I'm getting closer again. Now I've got the 1 and the 1. But I have this 7 that I need to be a 0. So if I take row 1 and I subtract 7 times row 2 and make that the new row 1. See, this is that like the challenge question we had. We're going to take row 1, we're going to multiply row 2 times 7 and subtract it from row 1, and that'll become the new row 1. So 7 times 0, so 1 minus 7 times 0. So this still stays a 1. Remember, the bottom row didn't change. Bottom row didn't change. So 1 minus 7 times 0 is still 1. 7 minus 7 times row 2. 7 times 1. 7 minus 7. 13 minus 7 times row 2. 7 times 2 is 14. So 13 minus 14 is minus 1. And now we have the solution. Because this is the X, this is the Y, and this is the constant. So if we turn these back into equations, what is this? We have 1x, no y's, and it equals negative 1. We have no x's, we have 1y, and it equals 2. That is the solution to this original systems of equation. 2x plus 4y equals 6, x minus 3y equals 7. Let's check that. 2x plus 4y equals 6. Well, if this is what the solution is, 2 times negative 1, since that's what x is, plus 4 times 2, since that's what y equals 6. 2 times negative 1 is negative 2. 4 times 2 is 8. And it does equal 6. So that works for the first equation. What about the second one? X minus 3y equals negative 7. Well, if x is negative 1 minus 3 times 2, because y is 2, does that equal negative 7? Negative 1 minus 3 times 2, minus 6. Negative 7 equals negative. So yes, this is the solution. We solved this linear equation using matrices. Just trying to manipulate the matrices to where we had a 1, 0, and then got the 0, 1 in the other column and got to our answer. All right, let's see. I do want to show you one other thing. with matrices. Then we'll go back to the buzz on look at this. There's one other thing we can do with matrices, which we will see on this week's assignment on the quiz. If we have two matrices that are the same size, that's kind of important. We can add them together. We'll get into this a little bit more later, but we can add these together. But here's the important part. If I'm going to add these matrices together, well, first of all, they have to be the same size. They're both 2 by 2s. So I add the same elements together. This is element 1, 1. This is element 1, 1. First row, first column. So that's 1 plus 0, which equals 1, right? Then, let me do this step. First row, second column. First row, second column. 2 plus 7 are 9. Second row, first column. 4 plus 9, that becomes 13. And the second row, second column. 7 plus -2 or 5. So we can add these two together and we get this. Add these two together. So there's going to be a problem on the quiz this week. So I'm giving you a preview. Does this make sense? You understand this? I hope so, because let's say you have a problem like this. 1, 3, 5, 7 plus 2, 4, x, and 8 equals let's see, 3, y, 10, and 15. What's x? What's y? Yeah, x is right there. Y is right there. Sure. 1 plus 2 is 3. 3 plus 4 is 7. Over here, you got 5 plus something is 10, and 7 plus 8 is 15. Well, 5 plus, well, it's got to be 5 if it's going to equal 10. So don't let that confuse you. You see that on the quiz. You're just adding those together. What's the answer? You'll see something like that on the quiz. I'll let you know. All right. Okay, we've looked at all that. Let's go back. Let's go back to Buzz. That was started in the unit. Yeah, don't forget to join the class. So we looked at matrix row operations. Here's the assignment to go with matrix row operations. When you click on that, just as a reminder for you guys, it'll take you to the 4 practice problems. I can close that. Take row 2, add 3 times row 1, and replace row 2. Right? So you'll do all of this, and you'll do 4 problems. Oh, I'm on problem 2 because I already did problem 1 yesterday, and they kept track of that. When you finish these, that's when you'll take a screenshot. At the end, when it tells me, good job, you got 4 out of 4, or 3 out of 4. If I got 3 out of 4, maybe I'll go back and do it again. Maybe I'll start over. Maybe I'll start and do it again. But I'll take my screenshot. I'll say, okay, here's my screenshot. You see, I got 4 out of 4. I'll go back here. And remember, you have to scroll down. Scroll down and paste your screenshot. There's my screenshot. It says I got 4 out of 4, and I'm going to submit it. paste your screenshot in that box. And then you're done with that. Okay, here's the only other thing I got besides the quiz. We're going to look at this one video, solving linear systems with matrices. He is going to do this just like I did on here. When I took these two and we stepped through to try to get to that 1001, that's what he's doing. So don't get confused by that. It's the same type of thing. What I'm trying to do is just giving you another example of it, another view. Okay, here we go.
Figure it never hurts getting as much practice as possible solving systems of linear equations. So let's solve this one. And what I'm going to do is I'm going to solve it using an augmented matrix, and I'm going to put it in reduced row echelon form. So what's the augmented matrix for this system of equations? 3 unknowns with 3 equations. So it'll be, I'll just have to do the coefficients. So the coefficients of the x terms are just 1, 1, 1. Coefficients of the y terms are 1, 2, and 3. Coefficients of the z terms are 1, 3, and 4. 1, 3, and 4. And let me show that it's augmented. And then they equal 3, 0, 3, 0, and minus 2. Now I want to get this augmented matrix into reduced row echelon form. So the first thing, I have a 1 leading 1 here. That's a pivot entry. Let me make everything else in that column equal to a 0. So I'm not going to change my first row. So it'll just be a 1, a 1, a 1, and then my dividing line, and then I have a 3. Now, to 0 this out, let me just replace the second row with the first row minus the second row. So 1 minus 1 is 0. 1 minus 2 is 1 minus 2. Actually, a better thing to do, because I eventually want this to be a 1 anyway. Let me replace this row with the second row minus the first row, instead of the first row minus the second row. I can do it either way. So the second row minus the first row. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And then 0 minus 3 is minus 3. Now, I want to also 0 this out. So let me replace this guy with this equation minus that equation. So 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. Minus 2 minus 3 is minus 5. Fair enough. So I got my pivot entry here. I have another pivot entry here. It's to the right of this one, which is what I want for reduced row echelon form. Now I need to target this entry and that entry, and I need to 0 them out. So let's do it. So I'm going to keep my second row the same. My second row is 0, 1, 2, and then I have a minus 3 in the augmented part of it. And to 0 this guy out, what I can do is I can replace the first row with the first row minus the second row. So I get 1 minus 0 is 1. 1 minus 1, there's a bird outside. Let me close my window. So where was I? I'm replacing the first row with the first row minus the second row. So 1 minus 0 is 1. 1 minus 1 is 0. No, I don't want to make it. 1 minus 1 is 0. 1 minus 2 is minus 1. And then 3 minus minus 3. So that's equal to 3 plus 3. So that's equal to 6. Right? 1 minus 0 is 1. 1 minus 1 is 0, negative 1. And then 3 minus negative 3, that's 6. I always want to make sure I don't make a careless mistake. Now let me get rid of this entry right here. Let me 0 that out. So let me replace the third row with the third row minus 2 times the second row. So we have 0 minus, well, 2 times 0. That's just going to be 0. 2 minus 2 times 1. That's 2 minus 2. That's 0. 3 minus 2 times 2. That's 3 minus 4, or minus 1. And then finally, minus 5 minus 2 times minus 3. Let me write that down. Minus 5 minus 2 times minus 3. That's minus 5 minus minus 6. That's minus 5 plus 6 is equal to 1. I really wanted to make sure I didn't make a careless mistake there. So that is equal to 1. So I'm almost done, but I'm still not in reduced row echelon form. This has to be a positive 1 in order to get there. It can't be anything other than a 1. That's just a style of reduced row echelon form. And then these guys up here have to be zeroed out. Well, the easy thing to do, let me just multiply this equation by minus 1. So then this becomes a plus 1, and then that becomes a minus 1. And then I just need to zero out these two guys up here. So let's do it. So my equation, I'm going to keep my third row the same. My third row is now 0, 0, 1, minus 1. 0, 0, 1, minus 1. And now I want to zero this guy out. So what I can do is I could set my first row equal to my first row plus my last row. Because if these two add up, they're going to be equal to 0. So what do I get? 1 plus 0 is 1. 0 plus 0 is 0. Minus 1 plus 1 is 0. 6 plus minus 1 is 5. Now I want to zero this row out. And to zero this row out, what I can do is I'll replace it with the second row minus 2 times the first row. Right? So 0 minus 2 times 0 is just 0. 1 minus 2 times 0 is just 1. 2 minus 2 times 1 is 0. Minus 3 minus 2 times negative 1. Let me write that down. Minus 3 minus 2 times minus 1. Don't want to make a careless mistake. So what is that equal to? This is equal to minus 3 minus 2, or minus 3 plus 2, which is equal to minus 1. So that's equal to minus 1. And now I have my augmented matrix in reduced row echelon form. Reduced row echelon form. My pivot entries are the only entries in their columns. Each pivot entry in each successive row is to the right of the pivot entry before it. And actually, I have no free variables. Every column has a pivot entry. So let's go back from the augmented matrix world and kind of put back our variables there. So what do we get? We get x plus 0y plus 0z is equal to 5. That's that row right there. We get 0x plus 1y plus 1y plus 0z is equal to minus 1. That's that row right there. And then finally, we have 0x plus 0y plus 1z is equal to minus 1. That's that row right there. And just like that, we've actually solved our system of 3 equations with 3 unknowns. That's the solution right there. I just wrote it in this way just so you see it corresponding, but obviously I could have written them closer to their equal sign. So hopefully you found that vaguely useful.
So the reduced row echelon form it's about is where we make it all ones and zeros. The variables, the x, the y, the z, those are all ones and zeros in reduced row echelon form. Now the constant column over on the right side, that can be whatever it needs to be. But the reduced row echelon was just ones and zeros, and there's only one on each row. All right, let's look at the quiz, and then I'll let you guys go. So let me put this up on the screen so you can see what you're doing for the quiz. The quiz, let me back up real quick and show you this. The quiz will give you more than one attempt. It says attempt 0 out of 3, so it's automatically set to let you have 2 retakes if you bomb it. All right, I wanted to show you this because it says, what are the dimensions of this matrix? Ignore all this gobbledygook on the second row, that long line of stuff. That's what I have to type in to make it display this matrix. Beginning, matrix, enter all these numbers, and so ignore that line. Just look at the matrix itself. Look at this is, the rows and the columns. So what's the dimensions of this matrix? There's your choices. What is the 3,2 element in this matrix? How would you write this systems of equations as a matrix? Multiple choice. There's 4 different matrices. Perform this row operation. If you take row 1 plus 4 times row 3 and replace row 3 with this matrix, which one of these 4 matrices is correct? And then here's that one I promised you was going to be on the quiz. What's X? What's Y? Now I did it with a 2 by 2. They're doing it with a 4 by 3. But what's X? It still works just as simple. They're just adding these two together. Since they're the same size, they can do that. All right, that's it, guys. You got the one assignment and then the one quiz this week. So altogether, that's 5 different things we've done on matrices. 3 last week, this week. I've seen a lot of high scores on this. If you don't do well on that, go back and do it again. If you don't get 4 out of 4 on the practice problems they give you on Khan Academy, go back and do it again. You can replace that. Give me your best score that you want to count in Buzz, what you want to count in Hack. So these are easier points than a lot of else we're doing. I'm seeing a lot of people scoring high on this that don't always score high on other assignments. So this is hopefully a unit that can help raise your grade, because matrices are not hard. They're just different. We don't work with them a whole lot. So take your time, do well with this, and go just butcher those matrices up and pull out all the info that you need out of that. Do well with that. So, all right, guys. I'm going to let you go, I guess, because we don't have anything new. If you wanna hang around, if you got questions, I'm happy to have you hang around. And otherwise, I'll give you the last half hour you could probably finish up the matrices and be done with for this week. So, have a great week, guys.